Hello friends, today we will go through the sanitary engineering numerical problem and we will determine the design discharge in the combined sewer. Here we are given a question, determine the design discharge for the combined sewer for the projected population of 50,000 numbers residing over an area of 20 hectares. The rate of water supply being 112 liters per capita per day and the concentration time is 30 minutes. Coefficient of runoff equals to 0.45. Assume 80% of water supply contributed to dry weather flow and the peak factor of 3. So this is our problem and we need to determine the discharge in the combined sewer. Now friends, we will write the given things in the question. So we are given the population P equals to 50,000 numbers. The water supply rate small q equals to 112 liters per capita per day. Coefficient of runoff equals to 0.45. Concentration time equals to 30 minutes. And in this case, we have assumed that concentration time of rainfall equals to rainfall time equals to 30 minutes. And now we will determine the discharge in the combined sewer. Now friends, we know that the discharge in the combined sewer is the sum of discharge in the sanitary sewer and the discharge in the storm sewer. Q sanitary and Q storm. So we shall determine the discharge associated with the sanitary sewer, likewise the discharge associated with the storm sewer. Now the discharge associated with the sanitary sewer, we shall determine Q sanitary first. Likewise, we will determine Q storm. Now, Q sanitary can be given by Q sanitary equals to peak factor into rate of water supply into population, number of population P. Now here we are given the peak factor to be 3 and we are given that the dry weather flow has been contributed by 80% of the water supply. So the rate of water supply shall be 80% of 112 into number of population is 50,000. So the answer will come out in liters per day. Now if you solve this, we will get 3 into 80 by 100 into 112 LPCD. So into liters, it will come in liters per day. So if you change liters into cubic meter, 1 liter equals to 10 to the power 4, sorry, minus 3 cubic meter. And in 1 day you have 86400 seconds into 50,000. So this shall come out to be in cubic meter per second. So the answer of Q sanitary shall come out to be 0.155 cubic meter per second. So this is the amount of sanitary sewage that is passing. Okay, like for Q storm. Now Q storm is given by the formula CIA by 360, where C is our coefficient of runoff, I is the rainfall intensity in mm per hour is the area, and this result will come out to be in cubic meter per second. Now for this, we have to find out intensity of rainfall first. So intensity of rainfall I can be given by the British Ministry of Health formula. So here we are given the concentration time as 30 minutes, and so we have assumed that concentration time equals to time of rainfall T. And for time of rainfall or time of storm greater than 20 minutes, we can use this empirical formula 1020 divided by T plus 20. So if you put the value of T as 30 minutes, then we will obtain the value of rainfall intensity as 20.4 mm per hour. So this shall be the amount of rainfall intensity in terms of mm per hour. Now, if we substitute the values of CIA in this above expression, we will easily get the value of Q storm. So C is our 0.45, I is recently obtained as 20.4, A is 20 hectares area given in the question and divided by 360. So this value comes out to be as 0.51. 0.51 cubic meters per second. So finally we can compute the combined discharge. Okay, so what is the amount of discharge that is passing in the combined sewer can be easily obtained by adding the obtained discharge in the sanitary sewer and the discharge in the storm sewer. So Q sanitary is our 0.155 plus Q storm is our 0.51. So if we add this, we will get the value of Q combined discharge in the combined sewer as 0.665. So 0.665 cubic meter per second will be the required answer in the combined sewer.